And then ellipsilon 5/4. We will not get it done. It's a big section. But for our review problem, I have two of them actually. Let's find the tangent of 207 pi over 4.
Which one's that?
This is a review problem.
Oh, it's all right.
Not in the notes. This goes on your review, wherever you're keeping track of reviews. I'm keeping track of mine in my little video notebook.
Don't do that.
Quit yawning, oh my god.
Come on, guys. Ow.
You guys,
It's always them. Where's my green paper? It's always the people.
alright, any thoughts on this? This is a review problem. Any thoughts on how we do this? What?
It's definitely gonna be a circle.
We're gonna look at a circle for sure,
Now you
but this angle is huge.
Yeah.
Would you agree? I mean, normally we're doing like 3 pi over 4 or something. This is huge. So let me write that as a mixed number. So 4 and 207.
51.
51 and 3/4. Would you agree with that?
Yep.
So I am finding the tangent of 51 and 3/4 pies. Now let's think about this for a second. If I go all the way around the circle, that's 2 pi. So what does this 51 pi represent? Could I
25
take out,
laps around.
could I take out 50 of those pies?
Yeah.
Because what would 50 of those pies represent? 25 spins, right? So I can, and that's nothing. I mean, that's just like this, so that's nothing. So I'm gonna ignore 50 of those and look at this, which is 7 pi over 4 if I put it back into fraction form. So first thing we did was recognize that is a big, big angle. If you were gonna draw that angle, you would just spin. So let's get all that spinning out. So I took out 50. Now, don't take out 51. Why do we have to take out an even number? Because a spin is 2 pi, right? Now, tell me about 7 pi over 4. It's 315.
So fourth quadrant.
So now I'm gonna look in the 4th quadrant. If this is 315, what's this? 45. What are my sides?
1, negative
1, root 2, and that one would be negative,
Yes.
right?
Yes.
I want tangent. Tangent is opposite over adjacent, so the tangent is negative 1. Okay, everybody good on that? All right, one more review problem. Directions, just like yesterday. And we're solving 4 cosine squared minus 1 equals 0. So how do you think we should
Add the one
start?
over. Add the one over.
Add 1 and maybe go ahead and divide by
Yep, and then
4.
square that both sides.
Square root both sides. So cosine equals, here comes the tricky part, plus or minus 1/2. Right? Now that means the cosine is going to be positive or negative.
Positive 1 or 3? No. 1.
Cosine is x, so it's positive
Oh, yeah, 1
here,
and 4, yeah.
right?
Or negative.
And it's negative here.
It's everywhere.
So we're everywhere, we're gonna have 4 answers to the problem. And you want cosine adjacent over hypotenuse, which means this is root 3, this is 60, and they're all 60. So now we gotta find our answers. So the first one is 60?
Yeah. Next one's 120.
Yes.
At 240.
The next one would be over here, and
120.
that would be
120 and then
120. The next one is all the way down here, so 180 and another 60. And then the last one is all the way over here, which is
300.
all the way around except for 60 degrees, so 360 minus 60, or 300. How do you feel about that?
Easy.
Easy. Easy. Where are we gonna make a mistake on
The
that?
plus or minus,
We're gonna forget that plus or minus, yeah.
that's where
So
I'm
be careful. When you square root, when you square root, make sure you are plus or minus. All right. Now, that's it for our chapter 4 review, but I wanna do a review problem from yesterday. So get your reference sheets out if you haven't gotten them out already.
What?
And we're going to do the sine of 75, and we're going to do it 2 ways.
Wait, what are we doing?
This is another review problem from yesterday, okay? So we're going to do the sine of 75 2 ways. So we're first of all going to do it with sum or difference, and then we're going to do it with the half angle formula. Okay, so let's start with the sum or difference. That means find 2 angles that either add or subtract to give you 75. And don't use things like, 68 and 7. No, pick known angles that add or subtract to 75.
45, 60, 15.
15 isn't known, right? 45 and 30.
Oh.
So sine 45 plus 30. All right, so you got your reference sheet. This is the sine of u plus v, right?
Sine 45.
So sine 45
Cos 30.
cosine 30
Sine cos
plus,
45.
new sign in, plus or minus in there, so plus
Sine 30.
sine 30 cosine 45. Now, I don't know which way you said that. It doesn't matter. All right, gotta have cosine 45 and sine 30 on this side, and they can be in either order, okay?
Need 2 root
Now,
2 over
we're
2.
going to plug in.
2 root 2 over 2.
So the 45s are root 2 over 2. So if you don't remember that, you can draw it over to the side and figure it out, but at 45s, we use them all the time, they're interchangeable, root 2 over 2, both of them. Now, 30 on the other hand, you might need to draw to remind yourself that the numbers are situated like that for 30. So the cosine
3 over 2.
is root 3 over 2, and the sine is 1/2. So we're gonna have root 6 plus root 2 over 4. Now, I graded, some of you turned your homeworks in, graded them. These don't combine. Don't be making that root 8. You can't do that. You can multiply them, but you can't add them, okay? Unless these numbers are the same. So this is it. All right, old news review, everybody okay with that? All right, now we're gonna do the same problem. We're gonna find the sine of 75, but we're gonna use the half angle formula,
So half of that.
okay? So, 75 is
150.
half of what?
150.
150. So we're gonna think of this as the sine of 150 over 2. Okay?
Root.
So we have a formula that says that's gonna be the square root of 1
Minus cos.
minus cosine 150. This is your theta right here,
Over
or
2.
your, whatever the variable I used is. That's your variable,
Over 2.
over 2. Okay, so now we figure out 150 would have a reference angle of 30. Be careful, that's a negative, right?
Yeah, so negative root 3 over 2.
So we have the square root of 1, actually it will be plus root 3 over 2
Negative.
because it's a negative. Does everybody see that?
Yeah.
The cosine is a negative number, so it's gonna be 1 plus. Now, that is a mess,
Multiply everything by 2.
so we'll multiply everything by 2, and that will at least get rid of that.
Yeah.
So now we have the square root of what? Square root of 2 plus root 3 over 4. And since 4 is a perfect square, we'll have the square root of 2 plus root 3, that's my numerator, over 2, because the square root of 4 is 2. Now, this answer right here and this answer right here are exactly the same number. They just come out looking differently. One thing I didn't talk about here, what about this formula?
Plus or minus.
There's a plus or minus out in front of it, but this is where you stop for a minute and say, okay, wait, I'm finding the sine of 75, right? Where's 75? Quadrant 1. What do I know about everything in quadrant 1? It's positive. If this had been a bigger number and it had been in quadrant 3 or something, then I would make it negative. Your sign, whether you choose plus or minus, depends on what quadrant is your problem in. Your problem's in quadrant 1, so everything will be positive,
Wait, so what's the answer?
right here.
Wouldn't the 2 be gone in the front? Oh, wait. Wait. What?
So I times everything by 2,
Yeah.
so I have a 2
Oh, yeah.
plus a root 3
Oh.
over 4. So I can't do anything with the 2 plus root 3, but the square root of 4 is 2.
Oh.
All right?
Yeah, radicals out there.
All right, let's get our notes out now. I gotta change my attendance real quick. Get your notes out. And
Friday, please.
no.
Yeah, it's Friday.
And we're ready for number 2. So we're on page 52, and we're ready to simplify. Now, we did some of these the other day, and you guys really did a good job with them. These are using your formula backwards, okay? So, when we have 1 minus the cosine over 2,
Cosine.
forget the number for a
47
minute.
over 2.
What formula is 1 minus cosine? Sine theta over 2. So this is your formula for the sine of theta over 2. What's your theta?
Oh,
47.
47. So what's this a formula for? The sine of 23.5?
Yeah.
that's the answer.
That's the answer.
And then the next one's 1.
No, it's not 1 because that's
It's a
a
minus, though.
minus. If it's a plus, you're all good, but it's a minus. So do you have a formula? Do you have anything on the page that looks like sine squared minus cosine squared? No, I mean on your reference sheet.
Oh.
Yeah.
Well, we have like sine pi over 2 minus theta equals cosine.
Okay, that would be a formula that would have to have the pi over 2 in it. And you don't have a pi over 2.
Cosine 20.
No,
You see one close to it?
I see
Sine point?
sine
Sine
pi over 2.
squared plus
Sine fade over 2. Sine
Okay.
fade over 2.
Sine squared close.
Sine fade over 2.
Okay, look down where, I gave my reference sheet away. Look down, right in the very middle of the page. It says cosine 2 theta.
Oh, that was 20.
But you didn't say that.
That was
Cosine 2 theta equals cosine squared minus sine squared.
I said, I definitely said that.
Okay, what happens when you subtract in the wrong order? This is your cosine 2 theta formula, but it is
Square.
backwards,
Oh, good.
right? So what happens when you subtract backwards? When you do
Get negative.
you get a negative. So this is the negative cosine 2 whatever, all right? Now, what's your theta in the problem?
87.
87. So this is the formula for the negative cosine 2 times 87, which is the formula for negative cosine 174.
Yeah.
We're gonna do some problems with the, what are known as the double angle formulas, that's this one. We haven't done any yet, but we will shortly. Okay, so just to make sure everybody's with us, if you have cosine squared minus sine squared, that's the cosine of 2 times the angle. That's your formula. That's the formula.
Yeah.
If you subtract anything backwards, then you get the same answer, you just get it negative.
Wait, what?
Because it was sine squared minus cosine squared,
Oh.
which is backwards of how it's supposed to be. All right, let's try the last one. What is that a formula for? Tangent what?
2 pi.
2 something,
That's 2.
right? What's the something in the problem?
73.
73. So that's a formula for the tangent of 146.
That's all you put?
That's all you have to put. You're just recognizing the formula and looking at backwards. Let me give you one more. What is the square root of 1 minus cosine 28 over 1 plus cosine 28? What is that?
That's
Find the formula first. It's the
Tan.
square root,
sine.
it's the
Tan theta
tangent
over 2.
of your angle divided by 2.
It's 14 of 14.
So this would be the tangent of 14, that's exactly right.
Wow.
See how it works?
Right there.
Oh, I see.
Find it, Owen? Alright, back in the old days, we had to memorize everything. You guys have it so easy.
No way you memorized
We have to memorize
it. No way.
How did you memorize that?
Yeah, how would you memorize that in like 2 weeks?
Because she did it.
Alright,
Long
sine 2x equals sine x, and we are solving from 0 to 360. So in other words, we're gonna solve in degrees, just like we did earlier. Now, let's hear a thought. Who has a thought? Anybody have a thought?
Divide by sine x.
Never,
Divide by,
ever,
yeah.
ever.
Divide by x.
Okay?
What if it's a 0?
So think of a big stop
Subtract
sign.
by sign.
Don't divide by variables,
So you
okay?
should have 0.
Hmm?
Equal to 0.
It could be. Oh, get it equal to 0? Yeah, that sounds like a good plan.
Yeah.
Yeah, I did that.
Let's get it equal to 0.
Yours is like, he's actually learning for a while, he usually doesn't learn anything. He's actually learning.
Now, we haven't encountered this, it's our first time,
Factor out
but
signs.
listen to me. 2x is different than x. So for example, if x is 10, 2x would be 20. And if you had a problem, it doesn't say this, but if you had a problem that said this, you cannot factor out the sign.
Yeah.
This is a decimal minus another decimal. So, you have two different variables in this problem. You are not going to factor.
No,
Instead, you're going to look at your sheet, and what is the sign of 2x equal to? Sine 2x, or 2 theta, or 2u, I don't know what it's.
2 sine theta cos theta.
2 sine cosine. So you have a 2x and an x in the same problem? Not good. So use your reference sheet to change the 2x into whatever it is. In this case, 2 sine cosine. Are you with me? Now, everything is x's. Now can I factor?
Yeah.
Yeah. So now I can factor out a sine. And what will I be left with?
Sine.
Sine.
Cos minus sine.
Sine times cosine.
No,
I took
it's
out a sine, so I'll be left
a
with,
sine cosine 1.
Sine
I
minus
took this out. So I'll be left with
2 cos.
2 cosine minus 1.
Oh.
Now, some of you are having some trouble factoring, and that's okay. It's really not okay, but it is what it is. If you're gonna factor, just distribute back and make sure it works for you, okay?
I think I'm just getting confused because you're like, you're
Now what?
I understand. Now you say both.
Set it equal to 0. So sine x equals 0, and 2 cosine minus 1 equals 0.
Okay.
Now, when I get zeros, what does that mean? I look on my unit circle. Remember, it's impossible for the opposite to be 0, the opposite side to be 0. So you're going to have to look on your circle. And I heard somebody say, where is y 0? And that's what we want. Where is y sine 0?
Negative 1.
Where's y 0?
One.
Right here?
The first one.
And right here?
Negative 1.
So what angles are those? This is what angle?
0.
0. And this is what angle? 180. So those are the answers to this part right here. Is everybody still on board?
Yep.
Okay, Jada, what's confusing you there? You were yawning and shaking your head.
I don't really know. I think I might have like zoned out or something.
Zone in, we're gonna do this one now. This one says cosine equals 1/2.
Yes.
Now that will be triangles. Cosine is x, it's positive. Where is x positive?
1.
1 and 4.
And 4. And the cosine adjacent over hypotenuse.
60 degrees, 60.
So this is root 3, that's 60 and that's 60.
60 and 300.
So my answers are 60 and 300, that's
Okay.
exactly right.
Good job, man. Wow. That makes sense. Just a lot of work. Not a lot of work to get there.
No, not bad at all.
I mean, but like, I get like a real
He's got to get a factor. What would I do?
I know he's
All right, so now we're on problem B. The directions are the same. cosine 2x equals cosine x. Who was paying attention to what we just did?
Me, I do the board. I'm doing the board. I'm doing the board.
So, what is wrong with our problem?
Move it over 0.
We're all set equal to 0. And then we notice that we have a 2x
Yes.
and an x.
Yes.
Can't do it.
So
So
that
we
would
go
be
to our sheet.
Yep.
cos squared minus sine squared.
Now, let's look at that with me. Yes, that's one option. But what do we notice about cosine 2x? It actually has 3 options.
Yeah.
Yeah.
That's 1 minus 2 sine and 2 cosine.
So you can pick the one you want.
Easier
all right. Look at the problem. See how there's a cosine right here? Wouldn't it be easiest to pick the version
With all
that's all
cos?
cosines?
Yeah, exactly.
So we're gonna do
So 2 cos squared
2 cosine squared minus 1
minus cosine.
minus cosine
We factor that, so we
equals
do
0.
cos times.
Hang on, you're right,
Just
hang
name,
on.
sorry.
Alright, is everybody with us?
Yeah.
So
Yeah.
this is one of those places where all of them will work. If you pick cosine squared minus sine squared, that will work. The problem is, there are gonna be more steps. Because ultimately, you want all your functions to match,
All crazy.
okay? Now, I'm gonna rearrange this.
Oh, you can do factoring.
That's what I was trying to do that.
And
then
it is a
2 cos.
quadratic.
I was trying to do that, but I went too fast for the rest of it.
You always
It's
do that.
like 2x squared minus x minus 1, that's what we got here.
Yep.
So we're gonna set up 2 parentheses,
2 cos x minus 1.
and you're gonna put a 2 cos x minus 1, I'm going with you, I don't know, and then cosine plus 1.
Yeah.
Yeah.
Alright, let's try it and see if that works.
Uh-uh.
Like all factoring, we just
Oh my God, go.
jump in, do it, and see if it works.
That is-
Foiling is be 2 cosine squared plus 2 cosine
Oh gosh.
minus cosine
Oh no.
minus 1.
I got it
Does
right.
that work?
Yeah, I got it right. Got it right.
No, that doesn't work. What's wrong with that?
You got back to the original equation.
It doesn't go back to the original.
How did? Oh, because it's negative
What
cos.
is
It's being
that
negative.
at?
Yeah, it's being negative cos. Yeah. I see.
That's positive, right?
Yeah, it has to be
And I need it to be
A negative.
negative.
So it's being negative 2 cos x.
So plus
And then yeah. Yeah.
minus.
Yeah.
I think that'll work. It's this one minus and that one plus. Yeah, that'll work. So I'm gonna stop here, and I want everybody to kind of catch your breath and catch up to us. So the first thing we did was figure out we needed to replace this. We chose to replace it with this. That's on my sheet. So then I moved things around a little bit and noticed it's in quadratic, it's a quadratic.
Yes.
So I factored it, we messed around with it for a minute, and finally got it to factor. And now we're here, this is where we are. This is my check. So 2 cosine x plus 1 is 0, or cosine x minus 1 equals 0. Alright, now what?
Subtract the 1 over.
So
Divide by 2.
solve.
So
So
cos
this
x
says
equals negative 1 half.
cosine equals negative 1/2,
Yep.
And the other one equals cos
That means
over
it's-
1. Equals
and
1.
cosine equals 1.
It's in the third. Oh wait.
So where is cosine
Second or third?
negative?
Second or third.
Second and third. And negative 1/2 means our angle is again 60.
Yeah.
Yeah.
So it's 120 and 240.
And so that would be
120.
120,
And then.
right? 180
And then
minus
240.
60. And this would be
40
240, 180
plus
plus 60.
I mean,
So 120 and
Drop this down.
240.
And the next one's 0 or 180. 0,
Because you take the 260s one.
Now, if it's a 1,
Let's get X.
That's on the circle.
Well, yeah,
Oh.
X is stuff.
Yeah.
Now, I heard somebody say 45. That's if the tangent's 1. If the tangent's 1, your angle is 45, because it's 1, 1. But if X is 1, you have to be somewhere on the circle.
Yep.
So where is X?
0, 360.
One.
And 180. No, 0 and 180.
See, right here.
0, bang, because
Oh
it's
wait,
X
X
over
is
R.
1, yeah.
X
X is
over R.
1.
Yeah. 0 and 180.
Only there, because at 180, it would be negative.
Oh, that's negative 1.
No. So why there, like, we put 0, not 360, or both of them are correct?
Well, no, they're not both correct, because the directions say
Oh,
that 0
yeah.
is included, but 360
It's not.
isn't. It's kind of redundant,
That's weird.
because doesn't the same thing happen
Yeah.
at 0 and 360?
Exactly.
So generally, we include 0 and not 360. If they were both included, you would write them both down.
Okay, that's just how it works. That's just how the rules are
Yeah.
set.
Okay?
Yeah.
All right, there's one more in this
And then
section.
we're done.
So I'm not gonna say anything, and I want you and your partner to see if you can make anything happen with problem C. Alright, so find somebody to talk to about it
Okay, so it's opposite, so it's 2.
and see if you can make anything work.
So we first. Opposite. So we already had cos, so we still left. So it'd be 1 plus, it was 1 minus 2 cos.
I know you did the last one, 'cause it's all codes.
Squared.
Part minus 1.
No, x plus 1. Because it's the opposite, we're gonna
Oh, yeah, yeah,
because it's a
yeah.
negative. Plus cos x. And then cos
And then
squared,
minus. And then
cos squared. Can we just, we can do cos squared. So negative cos squared, yeah, plus cos x plus 1.
Square x minus.
And I think we can factor, so negative cos
What's your equation?
x
Cos 2x plus cos
Cos
x minus
x.
cos 2x.
1 and 1.
I don't even know what
I think it'd be minus and plus. Okay. Factor that back out. Negative cos x
You have to factor it first.
minus cos x
I know.
minus cos x.
Yeah, I've just, I'm not
Let
gonna
me see if I got it right.
plus 1.
Okay,
Negative cos
so.
x
Well, I'm
plus
just
1.
accepting by defeat.
And then cos x minus.
You can't do it. Maybe it's 2 negatives. There we go, I got it. Minus cos x. That's
Yeah.
so. So they're the same, so you can just do 1. So, because you factor that back out, you get the same answer. Both negative. Both minus.
How do you get all
All right, let's see how far you got.
I don't know.
You started? Now,
I think that's pretty simple.
Wait, guys, that's perfectly okay, you can do that, that doesn't matter. But at this point, there's no factoring. You can't factor that. Why not? What's getting in the way?
There's variables,
There's a
variables.
2x.
Yeah.
Fix it. okay? So I think it's gonna be easier, I'm gonna leave the 2x over there for a minute anyway. And what am I gonna replace it with?
Two
Cosine squared minus 1, that's exactly right. Now, you have other things you can replace it with.
What?
But, as we pointed out, since the problem is already full of cosines, let's replace it with the formula that has cosines.
Yeah.
Would you agree it would be dumb to put 1 minus 2 sine squared in here?
Yeah, I agree.
Yeah.
See,
Okay.
we don't do that now.
We really
Alright,
don't.
you tried that?
Alright, now what?
Get it
Now
all
let's
on-
get it
now we
set
get
in.
it all
So
set.
I'm gonna do this, I'm gonna subtract cosine squared. I'm gonna subtract cosine. Are we, everybody
Definitely factor.
good to hear?
Quadratics.
Now,
Oh, yeah, I get that.
here's where we determine, you know, who are the A students and who are the not A students.
See, the factors,
That does not factor.
that's fine.
Now, our last one, it did, and so when we got to here, we went like this, and factored, it did great.
Quadratic formula.
What do we do when problems don't
Oh, I'm not
factor?
doing that.
Okay.
We use the quadratic
no.
Hey,
formula.
I'm A student.
I'll take the B
What's
student.
A? What's that?
Cos squared X.
No, A is 1.
What?
B is
Negative 1.
-1, and C
Negative
is
1.
-1.
Wait, what?
Your variable is cosine X. There's a 1 right there, right?
Yeah.
There's a 1 right here,
Negative.
and then you got that one. Alright, so here we go. Cosine X equals
1
negative B
plus or
plus
minus
or minus the square root of
1
B
minus
squared
4 times 1 C. Negative 1. Yep. So
all over
5.
2A.
So 1 plus root 5 over 2. 1 plus or minus root 5 over 2.
So let's separate them. There's two different answers, but let's separate them.
Okay.
So we're gonna have cosine X equals 1 plus the square root of 5 over 2.
Yeah.
Which, by the way, would you agree that would be a positive number?
Yeah.
So wherever the answer is, it's quadrant 1 or 4, because that's where cosine is positive.
Question on test.
And then cosine X equals 1 minus root 5 over 2, which is going to be a negative number,
So it's all four.
and that's gonna be in here and here. Now, it isn't all 4, but the angles are gonna be different, okay? The angles are gonna be different,
Wait, why would that be? Why is that?
because these are two different numbers. It's not like positive 1/2 and negative 1/2. This is some decimal, and this is a totally different decimal,
Whole number.
okay? Now, get your calculator out. And we can type that in, let's go ahead and do that, so let's do that. 1 plus the square root of 5
Over 2.
equals, divided by 2. Did you get 1.618? Okay, now, stop, that's not the angle. That's the cosine, right? So now we have to inverse cosine that answer. I got an error. What does that mean?
That circle.
That means this doesn't work.
It's circle.
That doesn't work. No,
How'd you
no,
get split down to
no. This has no answer. It's not on a circle or anything. It just didn't have.
Oh, so
It isn't there.
So what, she's what's on top? I got 15 minutes on left, I'm not gonna do that.
Okay. No, we haven't done this one yet.
Oh, okay.
Alright, so now we'll do 1 minus the square root of 5 equals, divided by 2. Did you get negative
0.62.
.618?
Yeah.
Okay. Now, that is not the angle, that's the cosine. So second cosine or inverse cosine, that decimal. So second cosine, second answer.
2.237.
128 is what I got. 128.17.
Oh, yeah, I'm in rating.
So 181 is 128.
Yeah, 128.
Oh, I see.
Okay. So the quadrant 2 angle is 128.17. All right. Would you agree that the quadrant 3 angle would be negative 128.17?
Oh, yeah.
Doesn't that make sense?
Yeah.
The problem is, I'm not allowed to have a negative answer. So what could I do to make that into a positive? Instead of going this way, go this way,
Yeah, which is just.
add, not 180, add 360.
Oh.
Don't I want to take this away from 360?
Yeah.
So minus 360. The other answer is 231.83.
Wow, that's a we did a lot today. We did a lot today. Wow.
We got time to do more.
Oh, we did.
Isn't that awesome?
I think that class like 13 minutes class.
Is it? Tell you what, we'll finish this page and we'll be done.
Oh,
So 2 were problems. Okay.
But that problem right there, guys, listen, that problem right there is like an honors caliber problem. That's a tough one.
honors.
These 2 problems are not hard. The last 2 are not hard.
Okay. Let's get
All right, here we go. The only difference is,
So that won't be on a test,
Ratings.
if it's an honors.
it
Might be.
depends if you guys make me mad or not.
I'm not.
I thought we were the famous
You know that old saying that nobody's happy unless mama's happy?
Oh.
Well, it's sort of like nobody's happy unless teacher's happy.
Just make mama happy,
So
right?
keep me happy.
Happy wife.
All right, so here we go.
Green. I know, but I was thinking.
We are now in radians. Nothing else, they're not making me happy. Nothing else matters or changes except now we're in radians. Okay, fine. So think about what we just did.
2 cosine
What's
squared.
gonna be our first step?
2 cosine squared minus
2 cosine squared minus 1
plus cosine.
plus cosine.
Just write that like in order.
And then we'll rearrange, get it in like the good factoring order. This one does factor. In fact, it may be the same problem
Why
we
did
did
you
before.
minus wait?
So we 2 cos.
Why did you go from plus cosine to minus cosine? Why did you go from plus?
Yeah, why did you go to
cosine
plus?
Oh,
to
it's supposed to be
minus?
plus, sorry, thanks. It shouldn't have gone that way, thank you.
Yeah. Pretty easy.
So what, 2 cosine,
Plus 1. Oh.
Yep, that's what I had.
that'll give me a positive 2 and a negative 1.
Yep.
So cosine equals 1/2, or cosine equals negative 1. Would everybody agree with that
Yep.
step?
Yep.
Okay, so this one I know is gonna be on my circle. So where is x negative
180,
1?
180, 180, 180.
Not 0. At 0, it's positive 1. But this answer is pi.
Yeah.
Yep, pi. I'm in radians now, that's the only difference. Where is the cosine? A positive 1/2.
One and 4.
1 and 4, and if this is 1/2,
60
this
to
is
60.
root 3.
So,
Be careful.
oh,
60
Pi divided by root
pi over 3.
is pi over 3.
And then 5 pi over 6.
5 pi over
6. 5 pi over 6.
5 pi over 3.
Wait, dang it.
Because all the way around is 6 thirds, right? 2 pi, 6
Yeah.
thirds. So if I go all the way around except for pi over 3, it'll be 5 pi over 3. And there are your 3 answers to this problem.
Next problem.
One more.
You can ready time with this one.
No, I'm gonna figure
Oh,
out.
she ended up being a, he's gonna milk it those 3.
Do you notice that you got a 2x in this problem also?
Yeah.
So you're gonna fix that. So what is sine 2x?
2 sine x cosine.
2 sine
X cosec.
cosine, yep. You don't have a choice on that one. That's it. That's the formula.
Yeah, that's all there is.
All right.
Subtract the 2 sine over.
Yep. Get it set equal to 0.
And then factor.
Wait, does that just
Back down
cancel
to
the 2
sine.
sine? Oh, wait, no, it doesn't.
Factor out a sine. 2 sine.
I can actually factor
2
out a
sine,
2
yeah.
sine. And what will I be left
Cos
with?
x minus 1.
Yep.
Cosine minus 1.
And then you set both those equal to 0.
So sine equals 0.
Yep.
Technically, it's 2 sine, but I'm
But
just
it
gonna
doesn't
divide by that 2, so it
Yeah.
won't matter.
So cos equals 1.
Or cos equals 1.
Alright.
Okay, so
So here's
Sine
my
y,
circle.
cos x.
Where is y 0?
9 or pi.
I divide
Pi was 0.
Pi and
3 pi.
3 pi.
0 and
Pi.
pi.
0 pi.
So 0 and pi.
cos is also 0.
Where is cosine x 1?
0.
That's 0?
Yeah. So
Already got
here you
that
have
one.
it.
So just 0
So
pi.
the answers are 0 and
Oh
pi.
my gosh, wow, we got it done.
I know. I wish I had not promised that.
Glad you
I would.